Hello, my name is Bruce Bunker. I'm a retired scientist. I have a PhD in inorganic chemistry. For most of my scientific career, I spent the time managing basic research projects within the National Laboratory System. One of those projects involved developing materials that could be used to capture carbon dioxide from coal-fired power plants in order to mitigate global warming. As a result of that project, I had to dive into the scientific literature regarding both carbon dioxide and global warming. And the deeper I dove, the more appalled I became. First of all, it became immediately apparent that the global warming narrative is based almost entirely on unsubstantiated claims. The frightening aspects of what I found were two things. The first one was I did not really recognize the extent to which the left has been willing to try to block all of the verifiable facts from ever reaching the public. And it's even worse than that. It became clear that the global warming movement has been making every attempt to both fabricate and falsify information in order to support what is a purely political agenda. I became so appalled that I decided I had to write a book about it called The Mythology of Global Warming. Most of the scientific literature and other source materials that I'm going to be talking about today have come out of that book. And what I'd like to do in today's presentation is really give you access to the facts that have not been allowed to get into the public in order to illustrate the folly of the Green New Deal. One fact that I think is undeniable is that fossil fuels provide the affordable and available energy that powers the American way of life. This facilitates our freedom, economic well-being, security, and comfort. Now, the socialist movement would take offense to that statement. They claim that the American way of life is evil, that the use of fossil fuels is destroying our planet, and that drastic and immediate government action is required to save the planet from global warming by completely transforming American society to adapt to a new renewable energy landscape. This socialist transformation is called the Green New Deal. In today's talk, I want to cover two different topics. In part one, we're going to really look at, does the planet really need to be saved? Are humans destroying the planet with fossil fuels? In the second part of the talk, we're going to look at the renewable energy landscape to see if the Green New Deal is actually a viable plan for saving it. But before we get into the actual facts, I want to share some thoughts with you regarding climate science. I believe in freedom of speech, freedom of thought, truth, and hard science that is backed by verifiable facts. I have been appalled by the extent to which our society has allowed the left to undermine all of these beliefs in support of the politically correct dogma of the worldwide socialist movement. I believe that political correctness probably represents one of the greatest threats to democracy, not only in America, but in the entire free world. Do you think that science is immune to political correctness? Well, think again. Climate science has actually degenerated to the point where it is nothing more than political science. For years, the left has been loudly proclaiming that 95% of scientists agree that the science of global warming is settled. In fact, they say that debate on this issue is no longer to be tolerated. Now, this 95% number is highly questionable, but there is no question that the left is never going to rest until they achieve total control of climate science. The left already dominates all information sources that the public has ready access to, including the media, academia, schools, and even government funding agencies. They have been using this power to suppress all information that's contrary to their agenda by labeling it either as disinformation or as preventing it from ever reaching the public in the first place. The second thing that they have done is the left has been ruthless in attempting to squash any scientist who opposes the party line. Do you want to get your paper published? Do you want to get your research grant funded? Do you want to keep your job? Some Democrat politicians, including Hillary Clinton and Bernie Sanders, were even advocating that so-called climate deniers should either be put in jail or into re-education camps. Is this how science is supposed to work? What are these people afraid of? Well, I'll tell you what they're afraid of. It turns out the science really is settled, and if the public had access to the accumulated knowledge of science and history that has been obtained throughout human life, they would find that hard science says that global warming is settled, that global warming is a fairy tale. And in spite of all the intimidation, a lot of scientists are still willing to say so, including 72 Nobel Prize winners who have signed petitions such as the Oregon petition, which say there is no convincing scientific evidence that the human release of carbon dioxide, methane, or any other greenhouse gas is causing catastrophic heating of the Earth's atmosphere and disruption of the Earth's climate. So in this part of the talk, we're going to get into those facts that these scientists are referring to. First, we're going to look at what really does control the Earth's climate. And secondly, we're going to look at both the real and imagined consequences of global warming. For starters, let's look at some facts that everybody can agree about. Regarding carbon dioxide is a greenhouse gas, and we'll get into what that means in a little bit. Second, fossil fuel combustion creates carbon dioxide gas, which is emitted into the atmosphere. And the third thing is that fossil fuel emissions have been rapidly increasing, particularly in China and the rest of the third world. And I want you to remember this graph on the left because it shows that the rise has been fairly exponential. In fact, it's 40 times greater now than it was in 1940. Now, regarding the climate, we have some also facts that everybody can agree on. The first one is that atmospheric carbon dioxide levels are increasing. They've gone up from, say, around 300 parts per million, where a part per million is 1 molecule per million molecules in the atmosphere, to about 420 parts per million, which is about a 30% increase. And this has happened since about 1880. The second observation is that climatic temperatures, are 1 to 2 degrees higher than they were in 1900. As a consequence, it looks like sea levels are rising, and that's due to melting ice. However, we now get into the realm of claims. Although these observations appear to be tied together in a very convenient package, the left has tied all of these observations together in order to formulate the central claims used to justify the entire global warming movement. These claims are the following. First, fossil fuel emissions control atmospheric CO2 concentrations. Second, atmospheric CO2 concentrations control the Earth's temperature. Third, the rising temperatures that we have been seeing are a direct result of the rising fossil fuel emissions. However, while each of these claims seems to be logical, not a single one of them is consistent with most of the scientific and historical evidence that has been collected over the last several hundred years. The actual connections between CO2, fossil fuel emissions, and climate are now going to be explored during the rest of this entire talk. Well, how can you say that these are just claims and not facts? Just look at Michael Mann's famous hockey stick graph that's taught to every school child in America. This graph shows what the Earth's temperature has done over the past 1,000 years. That curve shows that the Earth's climate was constant or even dropping prior to fossil fuel use. Then we had the Industrial Revolution, and as you've seen, this resulted in a huge rise in fossil fuel emissions. And sure enough, if you look at Michael Mann's curve, you get around to 1900 where the Industrial Revolution hit, and you see a huge rise in temperature. And in fact, that temperature rise looks almost exactly like the curve you saw for fossil fuel emissions going up. They've used those curves to actually quantify how much it goes up. And in fact, Michael Mann claims that the temperature goes up by 2 degrees Fahrenheit for every 120 part per million increase in atmospheric CO2. And if you look at the computer modelers, they're claiming it's even worse than that. It could be up to 6 degrees Fahrenheit for every 100 parts per million. This rising CO2 levels and temperatures are spiraling out of control. This means that drastic action must be taken immediately. And if we don't take action, there's going to be dire consequences. Earth is going to be converted into a hothouse like the planet Venus. All planetary ice is going to melt. There's going to be massive flooding of all coastal regions. There's going to be new destructive weather patterns, including hurricanes, tornadoes, droughts, floods, windstorms, even cold and snowstorms. On top of that, we're going to see massive extinctions and crop failures. It's going to be the end of humanity as we know it. Except there's just one little problem with this scenario, and that is that the classic climate curve that Michael Mann developed and has been used as the cornerstone of the entire global warming movement has since been shown to be fraudulent. With that prelude, let's take a step back and look at the mechanism of global warming. The Earth is constantly receiving massive amounts of light energy from the sun. That energy heats the Earth and it generates everything that we associate with climate: the wind, the waves, the evaporation of water, cloud formation, rain, snow, storms, and hurricanes. Not all of that heat goes into the climate, though. Some of it actually is radiated back into outer space. All warm objects emit what low-frequency light, and that low-frequency light is called infrared radiation. You can detect warm objects with that infrared radiation using things like night vision goggles. You can also feel that, even though you can't see it, in the form of radiant heat if you hold your hand up to the fireplace or up to any warm object. Now, the atmosphere, the main components of the atmosphere, which are nitrogen and oxygen, are transparent to this infrared radiation, and it just goes right on out into outer space. However, there are some gases that can absorb this infrared radiation. And when they do, it makes them vibrate faster, and this generates heat. So these gases are called greenhouse gases, and that is what is the mechanism for global warming. So what are these gases, and what are the most important greenhouse gases on Earth? Well, if you listen to the climate change people, of course, they always say carbon dioxide. Oh, that's the worst thing we've ever seen. However, if you're trying to wipe out the meat industry due to elimination of methane emissions from the rear end of cows, then you would say, oh no, methane's much worse than CO2. In fact, I've seen reports that say it's 30 times worse or 80 times worse. However, these claims made regarding the potency of both CO2 and methane ignore the facts. You don't have to guess about which gas dominates the greenhouse effect on Earth. You can measure it. And when you do, you find that water is by far the Earth's dominant greenhouse gas. And you can instinctively get a feel for this. If you go outside on a hot day, on a day that's got low humidity or a day that's got high humidity, on which day do you feel hotter? Well, with that digression, it turns out you can quantitatively measure the greenhouse effect of each of these gases. And it's equal to the product of the amount of infrared radiation that a single molecule can absorb times how many of those molecules are present in the atmosphere. In terms of the molecular absorbance, you can measure that using a technique called infrared spectroscopy. And an infrared spectrum of all the greenhouse gases is shown on this particular slide. The total absorbance is equal to the area under the peaks associated with each gas. And when you measure those areas, you find that a single water molecule absorbs about twice the amount of infrared radiation that CO2 or methane does. However, if we look at atmospheric concentrations, with the average relative humidity of water over the entire globe of 27,000 parts per million, it swamps what you have for either CO2 or methane. In terms of the Earth's total greenhouse effect, water is 140 times more potent than CO2 and 20,000 times more potent than methane. So, contrary to the claims of the global warming community, carbon dioxide and methane have a negligible impact on the Earth's greenhouse effect. And that means that both gases make a negligible contribution, less than 1%, to global warming. Well, how can you say that? What about that Michael Mann curve that we just saw, which shows that temperatures have been skyrocketing in response to CO2 emissions? Well, let's answer that question now by examining both temperatures and carbon dioxide records throughout time, starting with the last 100 years and going eventually back all the way back to the dawn of Earth's history. Well, first, modern temperatures do not scale with atmospheric CO2 levels. The curve on the left here shows a compilation of all temperatures reported by all weather stations across the continental United States for the past 140 years. And what you see is the temperature has gone both up and down. From 1880 to 1930, there was a temperature rise of about 2 degrees. In fact, by 1930, which is kind of in the middle of that curve, the temperature was warmer than it is today. From 1930 to 1970, there was actually a drop in temperature by 1.5 degrees. And the climate activists latched onto this climate drop as their first climate change issue. Climate scientists warn of global cooling due to the evil oil companies. Well, in Even Time and Newsweek, they put cover stories out, How to Survive the Coming Ice Age. Well, they had to kind of put those on the back shelf starting around 1970 because then the temperature started to rise again. And then the climate scientists had to change their story. Climate scientists warn of global warming. Okay, so that's what happened due to the measurements that were done at temperature stations. Now we have satellites in outer space that can measure the temperature not only of the United States, but of the entire globe, including the oceans. And when you do that, and you've looked at measurements that taken between 1999 and today, what you find is that the Earth's temperature has been essentially constant. And that's one of the rare times in all of Earth's history when that has happened. The bottom line is that fossil fuel emissions over this period have increased by over 10 times. Climatic temperatures show no such exponential increase. In other words, the climate models fail to represent reality. Well, how about the 1,000 years covered by Michael Mann's curve? Why hasn't he received the Nobel Prize for creating what has been called the most influential science graph of the 21st century? Well, for starters, to my knowledge, no one has been able to reproduce his graph. In fact, as shown on the bottom curve, the massive scientific and historical record, including such things as observations regarding changes in sea levels and crop distributions, shows that there have actually been 3 distinct climate periods over the last 1,000 years. First, there was the medieval warm period from about 1000 to 1500 AD, where the peak temperature was higher than it is today. This was followed by a cold episode called the Little Ice Age from 1500 to about 1850, which in turn was followed by the warmer climates that we're experiencing today. A specific example that validates the bottom curve involves the known advances and retreats of continental glaciers. Now, climatologists point to the current retreat of the Vatnajökull Glacier in Iceland. They wring their hands and they loudly proclaim that the end of the world is near. However, you can only believe that if you choose to ignore all of the other advances and retreats of glaciers that have occurred throughout human history. Image A on the right shows Iceland as the dark outline, with the current position of the Vatnajökull Glacier shown as the gray shaded region. This gray region has been blown up as a comparative reference in images B, C, and D, where the white regions show the extent of glaciation during different periods of history. In 8000 BC, which is shown in image A, aptly named Iceland was completely buried under the polar ice cap. However, by 4000 BC, which is shown in image B, when Egyptians were building the pyramids, almost all of the ice was completely gone. Several more advances and retreats then occurred. During the medieval warm period, when the Vikings colonized Iceland and even established coastal settlements and grew crops in Greenland, the glacier was smaller than the image shown as the white areas in image C. However, during the Little Ice Age, colder temperatures caused the glaciers to once again advance, forcing the Vikings to abandon Greenland. In fact, by 1750, Vatnajökull was so large that the Danes almost had to abandon Iceland at that time as well. Now let's revisit the Michael-Mann curve. Where is the medieval warm period? Where is the Little Ice Age? Well, the scientific community at large wanted answers to those questions. In fact, here's what 300 pages of scientific comments have to say about Michael-Mann's curve. The title of this book, which is 300 pages long, is A Disgrace to the Profession. And it contains comments such as this one from Professor Jonathan Jones of Oxford University. The hockey stick is obviously wrong. Everybody knows it is obviously wrong. Even many of its most outspoken public defenders know that it is obviously wrong. Do I expect you to publicly denounce the hockey stick as obvious drivel? Well, yes, that's what you should do. It is the job of scientists of integrity to expose pathological science. Right about this time, enough scientists got perturbed that they said, tell you what, we need to see the data. Show us the data that this curve is based on. They even used the Freedom of Information Act to try to get that information. And at about the same time, and here's what they had to say, what Mann and his colleagues had to say about that. The data was thrown out. We didn't really keep records of the data. The data was restricted for academic reasons. Well, that didn't satisfy a lot of people, and at around the same time, somebody succeeded in hacking into the email records of Michael-Mann and his colleagues. And that ended up generating this document. ClimateGate, caught green-handed. This tells about all the things that those people have been doing to falsify the climate change data. And in fact, one of the things that happened was that scientists were told to throw out the data. And not only that, Michael-Mann admitted that he had fudged the curve. Well, was there a massive dissent of investigative reporters that jumped on this story? Was there a massive public outcry? No, of course not. The media completely buried the story. There's nothing to see behind the curtain. And in fact, Michael-Mann's curve is being taught to school children to this very day. Well, if carbon dioxide isn't causing the climate changes that have been observed, what is during the past 1,000 years? And it turns out there's a simple answer to that. It turns out that the amount of energy that we receive from the sun is not constant, and that the temperature changes in Earth are tracking the changes in solar activity. Over the past 1,000 years, general trends in historical climate temperatures have followed solar activity as documented most recently by satellites, but it turns out you can do carbon-14 analysis of dead plant matter, and that tells you what the temperature did. You also have sunspot records going all the way back to ancient China that document these changes in solar activity. And you can see that the solar activity based on the carbon-14 analyses, which is shown on the right, is fairly similar to the actual temperature changes that have been observed. Now, at timescales longer than 1,000 years, other factors come into play that change the climate. Over the past 2.5 million years, there's been a repeating pattern of warming and cooling periods that we call ice ages. And these ice ages involve temperature swings that are considerably greater than can be explained based on changes in solar activity. Analyses of ice core samples have been able scientists to measure the fluctuations both in temperature, which is based on changes in the deuterium levels in the ice, and carbon dioxide levels, which is due to analyses of entrapped gases or bubbles that are in the ice. These analyses show that ice age temperatures and CO2 levels have never been constant. Regarding the temperature, the curve on the left shows that the Earth warms and then cools according to a complex periodic pattern that repeats every 100,000 years or so. And it turns out carbon dioxide levels, which are shown by the dots in the curve, also increase and decrease in sync with these temperature changes in each and every ice age cycle. Now, this complex pattern and these CO2 fluctuations are clearly not caused by humans. However, Al Gore and his fellow climatologists have been claiming that, well, look, what this really does is proves that CO2 controls the temperature. See, the CO2 and temperature track each other. There's just two little problems with that, though. The first one is that they can't explain what would make CO2 levels rise and fall in this complex repeating periodic pattern. The second thing is it turns out if you look at the data more closely, you find that the carbon dioxide changes actually lag behind the temperature changes by about 1,000 years. So in fact, carbon dioxide does not drive the temperature. The exact opposite is true. Changes in temperature are driving changes in atmospheric CO2 levels. All of this can be explained based on changes in the Earth's orbit that are called Milankovitch cycles. And that's shown on the right. The changes in the Earth's orbit are the one change is the orbit goes from being elliptical to almost circular. Another change is the Earth's axis that is tilted, and that tilt axis changes in a periodic fashion. And the final thing is that the axis precesses or wobbles around. You can exactly replicate the pattern of temperature changes based on these three periodic changes in the Earth's orbit. Well, what about the carbon dioxide? Well, anybody who has consumed a carbonated beverage knows that carbon dioxide dissolves in water. And it turns out, if you look at the amount of carbon dioxide in the oceans, it is 50 times greater than the CO2 level in the atmosphere. Another thing that you know from dealing with carbonated beverages is that carbon dioxide is less soluble in hot water than it is in cold water. So if you open a can of hot and cold soda, which one spews out more CO2 into the atmosphere? It's the hot one. Warming and cooling of the oceans releases and captures CO2 from the atmosphere, and that's what gives rise to this periodic pattern. In fact, the highest ice core CO2 level seen during human history was actually 500 parts per million, which is 20% higher than the CO2 levels we have today. And if you remember back to the glacier example of the Vatnajökull Glacier, that period during human history when the Egyptians were building the pyramids was exactly the same time when the temperatures were warming and the glaciers were melting. The 10-year geologic history of the Earth provides a final example, disproving the central claims of the climate change community. First one of these claims is that the temperature and CO2 levels that Earth is experiencing now have never been higher. Well, if you actually look at the CO2 levels and temperatures, which are in the top and bottom curves on this particular view graph, you can see the exact opposite is true. We are actually near the absolute lowest levels of both temperatures and CO2 levels in Earth's entire history. The hottest climates were about 20 degrees hotter than they are today, but you'll see that these temperatures do not track CO2 levels. The CO2 content of the atmosphere has gradually been declining over Earth's geologic history, where the temperatures have been oscillating back and forth. The two curves don't look anything like each other. Now let's evaluate the claims in the context of the climate model predictions. If you remember going back, Michael Mann and others said that the temperature should increase by by 2 degrees Fahrenheit for every 100 parts per million in CO2, or as high as 6 degrees Fahrenheit for every 100 parts per million. Even if it's only 2 degrees, this predicts that the ocean should boil away if the CO2 concentration exceeds 8,000 parts per million. Well, 3 billion years ago, the early atmosphere of Earth didn't consist of oxygen and nitrogen. It consisted of CO2 and nitrogen. And the CO2 concentration was 30%, or 300,000 parts per million. At that time, not only were oceans present, but oceanic life was already converting that carbon dioxide into oxygen. As another example, the worst ice age we've ever had in the Earth's geologic history occurred about 800 million years ago. And at that point in time, the CO2 level was 7,000 parts per million, or 17 times greater than it is today. Are we about to turn Earth into the planet Venus? Well, Venus has an equivalent CO2 concentration of 12 million parts per million. You could burn all fossil fuel reserves known on the planet, and even if all the emissions stayed in the atmosphere, which they don't, the CO2 level wouldn't even reach 1,100 parts per million. So in summary, neither atmospheric CO2, fossil fuels, or humans control the Earth's climate. All real climate changes and imagined climate catastrophes have a natural origin. And now I'm going to shift gears and we're going to take a quick look at the claims that have been made regarding those climate catastrophes. But keep in mind that not a single one of these claims matters if humans aren't to blame. The climate is going to do what it's going to do regardless of what humans do or what humans think. Well, first, climatologists claim that all ice on Earth is melting and that all coastal cities will soon disappear beneath the waves. And while it's true that continental glaciers like Vatnajökull are currently receding, in spite of the claims of the climatologists, satellite images show that the Arctic ice is not disappearing. In 2007, Al Gore cherry-picked a 2-year decline in the extent of the polar ice cap to claim that all of the ice would be gone by 2012. But then the ice mysteriously recovered. In 2013, government climatologists cherry-picked another 2-year period of decline to claim that all the ice would be gone by 2016. Then the ice recovered. In fact, the bottom line is if you look at all the data for all the years in recent history, the Arctic ice isn't going anywhere. In fact, the extent of the ice cap in 2021 was at a 30-year high. Not only that, even if the Arctic ice cap melted completely, sea levels wouldn't even rise by 1 millimeter. The Arctic ice cap and Antarctic ice shelves float on the Arctic and Antarctic oceans. And when floating ice melts, it contributes absolutely nothing to sea level, as the volume of water displaced by the ice exactly compensates for the volume occupied by the ice when it melts. And you can prove this at home by doing your own experiment. Put some ice in a glass of water, and as long as the ice isn't touching the bottom, you can put a mark on the glass to represent the sea level in your glass. Then go ahead and let the ice melt. Has the glass overflowed onto the floor? I think you'll find that the answer is no, and that there's no change in the sea level whatsoever. Finally, the graph on the right shows that 99% of all the ice on the Earth, 87% of which is in Antarctica and 12% in Greenland, is not about to melt. It's just too cold. Even in the tropics of Antarctica, the temperature rarely exceeds the melting point of water, which is 32 degrees Fahrenheit. But most of the ice is in the high plateau region, where the high temperature rarely exceeds 30 below zero and is as cold as minus 90 degrees for over half of the year. Yes, continental glaciers are melting, and this melting is causing sea levels to rise. However, it's time to put this rise into perspective. Sea levels are rising according to natural ice age cycles. Take a look at the curve on the left, which shows how much sea levels have risen since the end of the last ice age, when over half of North America was buried under the polar ice cap. This ice age ended due to a major warming period that started about 20,000 years ago. This warming was not generated due to a massive increase in the use of fossil fuels by cavemen or Native Americans. It was caused by the natural Milankovitch cycles that we discussed earlier in the talk. The result was a massive retreat of continental ice sheets accompanied by a massive rise in sea levels. In fact, it was 130 yards or around 400 feet. How does this rise compare with the modern rise in sea levels that climatologists are claiming represents the end of the world? Well, if you look at the top right of the left curve, you will see that while sea levels continue to rise, the rate of rise has slowed dramatically, starting about 8,000 years ago. In fact, it now looks about flat as a pancake. To view how much sea levels are currently rising, you have to magnify the sea level scale by a factor of around 500, and that's shown on the curve on the right. And there are three things to note regarding these modern changes. First, the rate of rise is well within the bounds of what is expected due to our current natural ice age cycle. Second, the rate of rise is not exhibiting the tenfold exponential increase that would track fossil fuel emissions. And finally, the rate of rise of 6 inches per 100 years does not represent a dire catastrophe. Humanity can readily adapt to the observed changes in sea levels, which are predicted to amount to around 20 feet over the next 4,000 years before the next ice age begins and triggers the next massive drop in sea levels. Let's go to the next claim. Is violent weather spiraling out of control? Once again, the answer is no. The curve blocks on the left show the number of Atlantic and Caribbean hurricanes by intensity, and you can see that we don't have any more hurricanes and they aren't any more intense. Tornadoes aren't any more severe or frequent either, which is shown on the right. In fact, if you were going to say anything, we're having fewer violent tornadoes than we had in 1940. Similarly, there have been no significant changes in the severity or frequency of temperature highs, temperature lows, floods, or droughts. Next slide. Is global warming causing mass extinctions? Once again, the answer is no. In fact, the exact opposite is true. Life thrives under global warming rather than global cooling. And you don't need to have an advanced degree in biology to know that this is true. Do plants grow better in the summer or in the winter? Does life flourish more in the Arctic or in the tropics? And if you look at CO2, plants breathe CO2 like we breathe oxygen. They need it to survive. That's the real greenhouse effect, and that's why gardeners pump CO2 into greenhouses to make plants grow. And by the way, contrary to all of the TV ads that you see, you don't have to worry about the polar bears going extinct. For starters, we've already seen that the Arctic ice habitat is not disappearing. In addition, the polar bears have survived 24 ice age cycles, each of one of which had less ice at the warmest part than we have today. And if you look at polar bear populations, they're actually booming. The current polar bear population is 3 times greater than it was in 1960. Now, if I was a climate scientist, I could say, ooh, look, climate is good for polar bears. But I have to admit that the reason for the increase in polar bear populations has to do with hunting bans, not the climate. Finally, regarding life, humans are no exceptions. Humanity thrives under global warming rather than cooling. Human civilization has relied on the warm period since the end of the last ice age in order to thrive. Warm periods coincide with increased food and water supplies, with the water supplies being higher because higher temperatures promote more evaporation from the oceans, which in turn leads to more precipitation. These climate optima promote human life. In contrast to that, colder climates tend to induce humanity's dark ages, characterized by starvation, poverty, and disease. So in summary, the environmentalists in the 1970s got it right. Humans need to fear global cooling, not global warming. That marks the end of this part of the talk. Now we're going to move into the second part, which deals with the consequences of the Green New Deal. Even if you still believe in global warming, is the Green New Deal going to solve this problem? Is it going to save the planet? Well, in this part of the talk, we're going to examine whether that's actually true. The claim that the left is making is that you don't have to worry about abandoning fossil fuels, because we're going to replace all of those evil fossil fuels with clean, green, renewable energy. So we're going to examine if this is remotely possible. In this part of the talk, I'm going to highlight facts that will allow one to evaluate whether wind and solar and renewable transportation can really do the job. And you will see that it is physically impossible for renewable energy to meet America's energy needs. Abolishing fossil fuels in America will have no impact on global warming. And in fact, if you abolish fossil fuels, what you're really doing is abolishing affordable energy, and that will have terrible consequences on the United States. Several years ago, the Department of Energy put together a flow sheet summarizing America's enormous energy landscape. This flow diagram shows where the energy comes from on the left and where it goes on the right. The first thing you need to appreciate is that the total annual energy consumption of the United States is a mind-boggling 17 billion barrels of oil, or 28 trillion kilowatt hours per year. So where does all this energy come from? Well, right now, the lion's share of that energy, 82%, comes from fossil fuels, with another 10% coming from nuclear energy. So that ends up being about 90% of our energy resources. Even with the massive investments that the government has been making over the last few years, solar and wind energy are around 7% of the grand total. Where does the energy go? Well, the left is claiming that renewable energy could soon provide most of our residential electricity, up from the 20% that it's providing today. Well, that may actually be possible. There's just one little problem, and that is residential electricity is only 11% of the total. The other 90% is being ignored. If you look at the big picture, our energy consumption can be roughly partitioned about 1/3 between electricity, transportation, and another 1/3 for heavy industry. So the question is, can all of this energy really be replaced by renewable energy? And if renewable energy is really as abundant, available, and affordable as oil, why haven't fossil fuels already been abandoned? Well, before answering that question, let's really take a good hard look at what the Green New Deal is really calling. Well, the Green New Deal is supposed to be required in order to prevent a worldwide crisis. In fact, for over 40 years now, the Democrats have been claiming that if we don't stop fossil fuel use within the next 10 years, the planet's going to be destroyed by irreversible global warming. What is their solution to this problem? Well, they're going to totally eliminate the use of fossil fuels, and on top of that, nuclear energy is evil, so we need to eliminate that as well. All of our energy is to be provided by clean, green, renewable sources. What are the consequences of that? I'm not going to sugarcoat it. The list is there. Most existing power plants are to be shut down. All vehicles having internal combustion engines are going to be outlawed. All air travel and transport is going to be abolished. Travel and shipping by water will be sharply curtailed. Military will be wiped out. You can't have an Air Force. You can't have a Navy. What about the Army? Well, let's just imagine Operation Desert Storm. Do we have the capability of calling for a ceasefire in the middle of that battle, saying, we're about out of our charges on all of our vehicles. You mind if we spend the next day or so recharging, and can you direct us to the nearest charging stations? It's total nonsense. Current farm equipment used to plant and harvest food will be abolished. Steel mills and heavy industries relying on massive on-site power generation are going to be outlawed. And all of the industries that we currently have that produce fossil fuels are going to be eliminated. The question is, are these drastic actions really going to save the planet? And can renewable energy really meet all of America's current energy requirements? In sharp contrast to all of the attractive attributes of fossil fuels, solar energy is inefficient, intermittent, localized, and expensive. First, consider collection efficiency, which I have listed as the energy collected per unit area in meters squared, where a square meter is about the same as a square yard. The maximum amount of energy reaching the Earth from the sun at noon at the equator is 1,000 watts per meter squared, which is enough to give you a suntan. The average as the sun traverses the sky from sunrise to sunset is 600 watts per meter squared. A photovoltaic solar collector has a maximum collection efficiency of around 15%, which means that the maximum average energy that you can collect in daylight hours is 90 watts per meter squared, or about equivalent to a 100-watt light bulb. If you cover your roof with solar panels, you can keep the lights on in your home on a sunny day. However, you certainly can't capture enough energy to run a blast furnace. In addition, the sun doesn't shine at night, which cuts the average collection for a 24-hour day in half. It also doesn't shine on cloudy days. In addition to inefficient and intermittent collection, the map on the right shows that there's a poor geographic distribution. Collection is relatively good in the state of New Mexico, but drops to less than half of that if you happen to live in New York. Battery backup is required, and there are huge land requirements. Solar energy also costs, in real costs, 5 to 7 times fossil fuels cost if you take away government subsidies. However, perhaps the largest issue that no one talks about is the huge amount of energy that's needed to make solar cells in the first place. You have to convert sand into silicon metal, and after that, you have to dope that silicon metal and fabricate it into semiconductor panels in processing facilities that are like the Intel processing plant. What this means is that a solar cell must operate for 30 years to offset the energy that's consumed in producing it in the first place. Solar cells have a limited lifetime of around 25 years, and that means that it takes more energy to produce a solar cell than it will eventually capture. It also means that solar cells have about the same carbon footprint as fossil fuels. But nobody notices or cares that 70% of our solar panels are made in China using coal-fired power plants. But that's okay if it's in China. Out of sight, out of mind. Okay, well, let's ignore production energy costs for a minute and look at wind energy. In terms of energy harvested, wind is even worse than solar. If you go outside on a windy day, does the wind propel you along? I hope not. Under optimum conditions, if you have a 3-masted schooner that has huge sails on it, you can propel that schooner along at, say, 5 to 10 miles an hour. However, do you have enough energy to move a modern cargo ship, or how about an aircraft carrier? That's the maximum you can get. However, conditions are rarely optimum. The wind doesn't always blow, or it blows so hard that you have to shut the facility down. This means that current wind facilities actually have a capacity factor of only about 30%, which means they're only really operating under optimum conditions about a third of the time. And that's when you have these wind farms in optimum locations. The turbines are huge, and interturbine spacings are also large, and that means that wind farm land requirements are huge. The net collection of energy per square meter over the wind installations we have now is about 1/7 that of solar. And just like solar, the geographic distribution is poor. And that's what's shown in the map on the right. If you happen to live in Texas and Oklahoma, boy, that's where the wind blows, and so you're doing pretty well. However, if you live on the east or west coast, you don't do as well. Once again, siting is problematic. Without government subsidies, wind is not affordable. It also costs about 7 times more than natural gas. And now let's talk about batteries for a minute. If you don't have fossil fuels to back them up, you have to have expensive battery backup. And you actually end up consuming a lot of energy just to charge the batteries so that you can harvest energy later. In terms of the cost, a good example is the Hornsdale Wind Farm in Australia. That wind farm cost $25 million to build. The battery backup cost $50 million. You may be wondering why I've been harping on the energy per unit area, and there's one important reason for that. Regardless of how much the left wants to adopt renewable energy sources or how many trillions of dollars the government wishes to spend, renewable energy will never meet America's current energy needs for one simple reason. There just isn't enough land available to provide adequate harvesting. Land is a valuable resource. Now, we're used to fossil fuel and nuclear plants that are actually efficient and whose land requirements are minimal. That is not the case for renewable energy sources. And that is illustrated on that map that's shown on the right there of the San Francisco Bay Area, showing the comparative land requirements of a 1,000 megawatt nuclear plant, which is the teeny circle, versus solar, which is the medium-sized circle, and wind, which is the large circle. And you'll see that solar requires almost 100 times more land than nuclear or fossil fuels and 700 times more land for wind. The total land area in the continental U.S. is about 3.1 million square miles. The land requirements needed to match current energy consumption. Solar requires about 350,000 square miles, which is equivalent to 100% of every square foot of land in Arizona, New Mexico, and Nevada. And wind, you can't even do it. It exceeds the total land mass of the United States. So, who is going to pay for the massive amounts of land required by the Green New Deal? Who's going to give up all that land? Well, based on physical limitations alone, you'll never have more than 20% of current U.S. energy needs supplied by solar and wind energy. Moving on, let's examine the Democrats' schemes and claims regarding renewable transportation, starting with electric cars. Well, a Tesla is a technological marvel. It's fun to drive, and it's probably a good vehicle for impressing your liberal friends. However, if you think you're saving the planet with it, you're kidding yourself. In the short term, where does all of the electricity for charging that electric car come from? Well, it comes from a fossil fuel plant. In fact, if you factor in resistive losses associated with charging the vehicle, the current CO2 footprint of a Tesla is almost the same as that of a fossil fuel car. You've got charging times of 5 hours versus 5 minutes if you pull into the gas station. Replacing the batteries, you have to do that about every 8 years, and that costs about $20,000. But now we get to the real problem, and that's a long-term problem. Where are the batteries for all of these electric vehicles going to come from? The battery ferry? It turns out if you look at the reserves that are available for making batteries, lithium, cobalt, and nickel, you find out that you're going to run out really quickly. For example, let's look at cobalt. The world's reserve for if there is absolutely no change in demand from today is 60 years. Now, right now, only 4% of the cars and light trucks in America are electric. If you're going to make them all electric, you'd have to increase that by a factor of 25. And that's for cars alone. That means it can't be done. There isn't enough cobalt to go around. Let's move on to the next item here, which is fuel cells. Some politicians, including our governor in New Mexico, are proposing that we should go to fuel cell economy for propelling our cars. This is supposed to be a lot cleaner and greener than fossil fuels. And it has the added advantage that in New Mexico, we have a substantial oil and gas industry, and this is a way of supposedly salvaging that industry without producing CO2. A fuel cell is like a battery where the fuel comes from the outside. And the classical reaction in the fuel cell is you react hydrogen with oxygen and you make water. So the only emission from the fuel cell is water. What could be cleaner or greener than that? And not only that, you could pull into a hydrogen station like you pull into a gas station. There's just one little problem. Where does the hydrogen come from? It all has to be produced. And the production consumes more energy than the fuel cells provide. Although hydrogen is a colorless gas, the left has identified two distinct kinds of hydrogen depending on how it's produced. Green hydrogen, what you do is you stick a couple electrodes in a vat of water and crank up the power, and you can fry the water and make it into hydrogen and oxygen. That's pretty clean. Trouble is, it's energy intensive, and you eat up a lot more energy than you ever get back from the hydrogen. That's not how industry makes hydrogen. They make it blue hydrogen. In that case, what they do is they take things like methane, react that with water in high temperature, high pressure steam, and that generates hydrogen, except there's a little problem. The reaction, if it's run to completion, makes carbon dioxide. In fact, it makes as much carbon dioxide as a fossil fuel would make. If you don't run it to completion, you make carbon monoxide, which is a toxic gas. Not only that, but the left hates this fuel cell concept on principle, because the main point is to wipe out the fossil fuel industry, not to save it. Finally, let's look at biofuels. Well, it's clean and green. It's renewable. You can grow a crop of fuel each and every year. Well, the problem is, what is that fuel? What you're basically doing is you're making gasoline out of plants. And the CO2 that you get from burning a biofuel isn't any cleaner or greener than what you get out of gasoline. And it's worse than that. Because if you factor in the amount of fuel that's required to plant, harvest, and process biofuels, you end up consuming a lot more fuel and generating a lot more CO2 than if you just use gasoline in the first place. Biofuels consume massive farmland, and we're all seeing that food prices are going out the roof. So do we want to put our farmland into biofuels? I don't think so. Finally, biofuels are much more expensive than gas. In fact, the bioaviation fuel that was being proposed under President Obama costs almost $60 a gallon. Although given Biden's efforts to increase gas prices, maybe they'll be comparable by the time he's done. What about the electrical power grid? That grid is already struggling to meet existing electricity needs. So what are we going to do? If we're going to actually go entirely to renewable energy, we're going to need to triple the capacity of that grid to not only handle existing electricity, but to also cover all electrical transportation and all electrical heavy industry. The problems with the green power plants are we're going to have to replace all of the existing power plants with the renewable ones. We're going to have 3 times more plants, and the land requirements we've already seen for doing all that are astronomical. What about the power grid? The grid is already struggling to meet existing energy needs, and we're seeing increasing brownouts and blackouts, particularly in those states that have adopted renewable energy schemes. Massive increases in transmission lines are going to be needed, and that's to more than triple capacity to transport electricity from regions where the electricity is generated, which are those blue regions on the map on the right, to regions where the electricity is consumed, which is where all the black dots are in the map. And who's going to pay for the trillions of dollars needed for the complete overhaul and threefold expansion of both our electrical generation and transmission capabilities? I think you know the answer to that. The real problem with fossil fuels is not that they are destroying the planet. The problem is that they are not renewable. In fact, current reserves are predicted to run out in about 250 years. We've already seen that solar and wind energy are not up to the task of replacing all of that energy. So what are we going to do? Well, it looks like the real prospects for America's energy future are almost certainly going to lie with nuclear energy. All current reactors rely on fission energy, which is shown on the left. The real advantage of fission energy is it's the maximum possible energy that you can get on a per atom basis. In fact, one uranium atom falls apart, it releases 200 million electron volts of energy. And to put that number in perspective, if you capture a photon of light in a photovoltaic device, that's 2 electron volts, or 100 million times less than what you get out of nuclear energy. Now, there are, of course, the left hates nuclear energy, maybe even more than they hate fossil fuels. And the way that they attack that industry is on the basis of nuclear waste. But because the energy density is so high, the amount of nuclear waste that are generated are actually fairly negligible, and they're also not nearly as hazardous as the left would like you to believe. There is a problem, though, and that is, like fossil fuels, uranium represents a non-renewable resource. There's about a 230-year supply given existing mines. However, you can extract uranium from seawater. If you do that, the supply would last on the order of 60,000 years. The problem with that is you end up doubling the cost of electricity. But, that's evil, whereas the 5-fold increase we would have for solar and wind, that's great. In the long term, though, there's another solution that's also nuclear energy, and that's fusion energy. This is the reaction that powers the sun, so you could say that's real solar energy. The energy density of fusion energy is still very high. The supply of fuel, which is deuterium and water, is limitless, and it will have benign environmental impact. The problem is that because it's the energy source that powers the sun, it also happens to require the extreme temperatures and pressures that replicate what's in the sun. That sounds like it would be impossible to do, but Lockheed Martin has been using magnetic confinement, and they claim they might even have a fusion reaction in 10 years or so. Now, I kind of doubt that that's true. However, if the government would fund a Manhattan Project scale research activity, I'm sure it would be achievable. And investing in an energy future based on fusion makes a lot more sense to me than investing in the Green New Deal. Well, we're entering the home stretch now, and we can start looking at the real impact of the Green New Deal on CO2 emissions and on the United States. The Democrats like to pretend that humans are the only source of atmospheric CO2 and that the evil United States is the only country that's spewing CO2 in the atmosphere. Both of these claims are false. First, nature contributes much more CO2 into the atmosphere than humans do. Human breath alone is about 10% of fossil fuel emissions, but if you look at all biological sources, especially the fungi and other microorganisms responsible for the plant decay processes that recycle dead plant matter back into the atmosphere as CO2, you find that fossil fuel emissions only amount to about 6.5% of total global emissions. In addition, the United States is not the only source of fossil fuel emissions. In fact, we only are accounting for 14% of global emissions, with China and the developing nations leading the way. The bottom line is that natural emissions dwarf fossil fuel emissions. Worldwide fossil fuel emissions dwarf American emissions, and renewable energy in the United States has reduced the world's fossil fuel carbon footprint by 0.1%. Total implementation of the Green New Deal would lower global CO2 emissions by a maximum of 1%. And if you throw water into the mix, this reduces the Earth's total greenhouse effect by 0.007%, or 1 part in 15,000. Nothing good will come from the Green New Deal in order to have a negligible impact on a non-existent problem. First, look at the impact it has on our energy landscape. You can expect to see more recurring and frequent brownouts and blackouts. There's going to be the elimination of gasoline, which curtails and disrupts transportation and food and supplies. And of course, the most important fact is that renewable energy alone will never provide more than 20% or 1/5 of the energy that we use today. Overhauling America to make it totally dependent on solar and wind energy will also cost over $100 trillion, which is 4 times the value of all goods and services in the United States. And this is to make all new power plants, transmission lines, and mass transport systems. What is the impact of this $100 trillion? Well, it has a massive consequences for the economy, including massive federal deficits, runaway inflation, and massive tax increases. The impact on business: you'll end up bankrupting the current energy sector. And in New Mexico, which is the state I live in, this would wipe out the major commercial source of income for the entire state. What about the impact on individual Americans? What you're going to see is escalating costs of electricity, transportation, and food, reductions in take-home pay due to taxation, and massive losses in purchasing power due to inflation, in addition to massive job loss. Is any of this good for the average American? Then why are they doing it? The sad fact is that their primary motivation for reaping all of this destruction is the transfer of massive economic resources and power to big government. If the average American really knew what was going on, they would never support the Green New Deal. But the Democrats don't care. They're going to do it anyway. They've been disguising the Green New Deal in other massive trillion-dollar spending bills like the infrastructure bill and the Build Back Better bill. They're also pushing their agenda through non-legislative processes that nobody votes for. This is being led by the Biden administration. These actions impact every dimension of our energy landscape, starting with transportation. The first goal they have is to force people to abandon gas for vehicles. The policies they're imposing are designed to sharply curtail domestic oil supplies by doing things like prohibiting oil and drilling or leasing on all federal lands, which is 25% of all of our oil, and canceling all new pipelines. The Keystone Pipeline alone represents 15% of the oil that we would be using. Now, instead of being energy independent and an oil exporter, we are suddenly importing 40% of our oil. What are the consequences of that? Well, we've seen a doubling of gas prices in less than 2 years. This doubling is not due to Ukraine. It is not due to the evil oil companies. It's due to the simple laws of supply and demand. If you have the demand stay constant and the supply is cut in half, the price is going to double. And this has been done deliberately. Most Americans don't like it. So how did the Democrats respond when confronted with this fact? To show empathy for the little guy, here's some of the comments that they've made. One of them is, "Who cares? I drive a Tesla." Another one is, "We don't care whether you don't like the high cost of gas. If you don't like it, ride in the bus." Well, there's more consequences than just the doubling of the oil prices. We're fueling inflation. So the guy with the Tesla is not immune. Everything that we have is transported using fossil fuels. So if the costs go up, everybody's costs go up. We're also jeopardizing U.S. security by forcing importation of oil from a lot of America's enemies, including Russia, Iran, and Venezuela. The Biden administration has also been seriously depleting the strategic oil reserve, which is supposed to be used for national crises. And that's not all. Their latest goal is to force automobile manufacturers to abandon gas-powered vehicles. And the way they're doing this is by setting unrealistic goals for fleet gas mileage. 50 miles per the gallon by 2026 versus 25 miles of the gallon per day. It can't be done with standard gas-powered cars. So this means that all consumers are going to be forced to either buy electric cars or motorcycles, as manufacturers will not be allowed to produce anything else. And this is going to produce massive disruptions to all vehicular transportation. Well, what about the business and heavy industry sector? The goal there is to force businesses to abandon fossil fuels. The policy that they're using there is called cap and trade. And what they do there is they mandate unattainable caps on fuel use that companies can exceed only by paying government extortion in the form of extreme taxes or fines. The consequences of that policy is to force businesses to either pay the tax and charge more to consumers, move elsewhere, or go bankrupt. Getting to personal electricity, this is the most insidious one. We've seen that available energy is going to be cut by 80%. And one way to put that in perspective, that means that instead of being able to use energy every day, you can use it one day a week. Well, who's going to decide who gets to use this energy? You know the answer: big government. So their goal is to police and ration consumer consumption of electricity. And they're doing this already by establishing what's called the smart grid. And what they're doing is they're monitoring and controlling the electricity, not only going to each individual home, but to each individual appliance in your home. The consequence: total loss of freedom. Here's some examples. Mrs. Smith, we caught you washing your clothes twice this week. That means we're going to have to cut your electric ration. Mr. Jones, your neighbor overheard you say something that wasn't politically correct. I'm afraid we're going to have to send your electricity allocation to more loyal party members. Why are the Democrats deliberately seeking all of this destruction? It turns out they don't care what your quality of life is. They don't care what your economic well-being is. All they care about is seeking ultimate power over your life. Remember, the Green New Deal is a socialist program. And also remember that these people hate the United States. So their goal is to cripple the United States as the leader of the free world, reduce energy resources in the U.S. by 80%, cripple the U.S. economy, and gut the U.S. military. What they want to do is transform the United States into a communist country by capturing the entire U.S. energy sector. The Green New Deal is going to allow them to dictate energy use to businesses, as we've already seen with things like cap and trade, and they're going to end up being able to control all business activities. They can also dictate energy use by individuals, control and dictate all transportation, control all jobs, extinguish all freedom. The bottom line is, if you capture the energy sector, this will facilitate the end of freedom in America. In conclusion, I believe that the greatest danger to America is not global warming. The greatest threats to the American way of life are the global warming movement and the Green New Deal. All Americans need to be made aware of the dangers they are facing and stop voting for the people who are supporting these destructive policies before it is too late.